Today we are going to learn about the new concept called wavefront. The concept of wavefront was introduced by the scientist called Huygens. Now we will see what is a wavefront. As per Huygens theory, that light travels in the form of wave in all direction. Just I have drawn the waves which are originating from the source and it is traveling in all directions. Not only on the surface of the board, you have to imagine that the light is traveling towards you and even it is traveling towards the blackboard also. Are you clear? Now, in any wave, let us draw a single wave. In any wave, we are able to locate certain points. Are you clear? So, these positions are called as angular positions. The angular positions of the wave, they are called as phase. Here the angular position of the wave can be taken as 0. Here the angular position of the wave can be taken as pi by 2, 90. Here it is taken as pi. Here this one can be taken as 3 pi by 2 or 270. Here this one can be taken as 2 pi. So the phase of the particle in a wave is 0 here, the phase is 90 here, phase is pi here, the phase is 3 pi by 2, here the phase of the particle is 2 pi. Now in this particular arrangement, we have to locate the points which are having the same phase. Here what is the phase of the particle as per the diagram? Pi by 2, here also 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 pi by 2. Okay, now all the points to be connected now. If you connect all the points, roughly I am connecting, you won't get the exact shape. Okay, now I am going to connect all the points together. So what you are getting? You are getting a circle. Are you clear? So since it is a blackboard, just I could draw the circle. But since the wave is traveling in all direction, if all points are connected with the particle which are having the same vibration, state of vibration with the phase 90, you will get a sphere. You will get a spherical shaped structure. That imaginary spherical shaped structure is called, what is this? Wavefront. How the shape of the wavefront will be? The shape of the wavefront will be spherical in nature. So you will be getting a spherical shaped wavefront. Are you clear? So here what I have done, I have drawn the locus. I have drawn the locus. What is locus? That locus is the connecting line which connects all the particles which are having the same state of vibration. Look at that, even with the help of some other word we can explain. So this is the point called crest. This is the point called trough. So this, look at the point, this is the crest point. This is also a crest point. Crest, crest, crest. All the crests are connected here. After connecting the crest, that crests are connected by means of a locus. That locus that gives you the new concept called, what is this? Wavefront. That locus itself is called as wavefront. Are you clear? How the shape of the wavefront will be? Spherical wavefront. Now I am going to choose to clear another point. This is the phase of the particle, where the phase of the particle is 180. That is pi. Here also pi. Here also pi. Here also pi. Here also pi. Now you connect all the point now. After connecting all the points with the phase of pi, you will get another wavefront. How the shape of the wavefront is? The shape of the wavefront is spherical in nature. So this is the first wavefront. This is the second wavefront. So this is the locus of all the points which are having the phase of 180. Now I can draw another locus which are having the same state of vibration. Okay, that is 3 pi by 2. Connect now, you will get another locus. This locus that gives you the another spherical wavefront. So like that we can draw innumerable number of wavefront, which are originating from the source. First wavefront, second wavefront, third wavefront. Like that we are able to draw infinite number of wavefront when the ray travels in the forward direction. So nearer to the source, the shape of the wavefront will be spherical in nature. Nearer to the source of light, how the wavefront will be? The wavefront will be spherical in nature. How the rays are? The rays are divergent. They are diverging. So note down, nearer to the source, I will write nearer to the source of light, the nature of the wavefront will be spherical in nature. How the ray will be? The rays will be in the form of divergent. So divergent rays could be seen very close to the source. Make a note. Are you clear? Very important. Very close to the source. Always which kind of wavefront will be appearing? Spherical wavefront will be appearing. And what kind of rays are originating? Divergent rays. Are you clear? So I have introduced about the spherical wavefront. Now I am going to introduce another kind of wavefront. Let us imagine a fluorescent lamp, tube light. Okay, the shape of the tube light, it is in the form of cylindrical in nature. So in the case of tube light, how the shape of the wavefront will be? Look at that. Here, this is the first wave. This is the second wave. Are you clear? So here, this is the phase of the particle 90-90. If both are connected, so I have to draw several number of rays. Just I am connecting these two 90 phase particles. What you are getting? You are getting a first wavefront. How the shape of the wavefront is? The shape of the wavefront is cylindrical in nature. So I could draw cylindrical wavefront around the cylindrically shaped source. So this is the real source. There from which kind of wavefronts are originating? Cylindrical shaped wavefronts are originating. So this is the next wavefront. Are you clear? So wavefront 1, cylindrical wavefront 1, cylindrical wavefront 2, cylindrical wavefront 3, like that. For different phase of particle, after connecting the locus, you are getting different wavelength and they are traveling in the forward direction. How the rays can be drawn? So this is they are all the divergent rays which are originating from the source. So nearer to the source, what kind of rays could be seen? Nearer to the source, divergent rays could be seen and cylindrical wavefronts are created in the cylindrically shaped source. Cylindrical wavefront is created very close to the source. Are you clear? And then what kind of rays are created? Divergent rays are originating from the source. Make a note. Okay, very close to the source. So clear? Nearer to the point source, spherical wavefront will be created. Divergent rays are produced. Very close to the cylindrical source, cylindrical wavefront will be produced and divergent rays are originating from the source. Don't forget. Now we are going to see what will be the shape of the wavefront. Is it clear? When it is traveling far from the source. Is it clear? You are here. What kind of wavefront you will be receiving? Look at that. Here nearer to the source, spherical wavefronts are seen. Now, if you move far away from the source, you are here. Which kind of wavefront you will be receiving? Look at that. So here, if the journey continues, how the wavefront must be drawn? Look at that. This is the next wavefront. This is the next wavefront. So the size of the wavefront, it is going on enlarging. So here, I can't draw the complete spherical wavefront structure. Just I can draw the part of the wavefront. Still it is spherical in nature. See that? Now slowly I have drawn the part of the circle. I am here. What kind of wavefront I will be receiving? Look at that. This is the part of the circle. Don't forget. This is the part of the spherical wavefront. While receiving, while incident on me, what kind of wavefront will be? Look at that. Here I am receiving a plane wavefront. So the plane wavefront is the part of the spherical wavefront. Make a note. Here also I can draw a small plane wavefront. On the surface of the spherical wavefront I can draw a small plane wavefront. Here also I can draw a plane wavefront. So within the spherical wavefront structure I can take a small portion. There I can draw the small plane wavefront. Are you clear? What kind of wavefront is clear can be assumed? A small bit of spherical wavefront can be taken as a plane wavefront. Are you clear? So plane wavefront is nothing but it is a part of the spherical wavefront. Where it will appear? That one will appear only if you are very far from the source. Are you clear? I will tell you one best example. Let us imagine this is the sun. Sun is also a best source of light. Very closer to the sun in the vast space. Clear, the space is very vast. In that sun, it occupies a very small portion. Sun can be taken as a point source. Sun can be taken as a point source in the space. Are you clear? Very close to the sun. How the nature of the wavefront will be? Then the nature of the wavefront will be spherical in nature. But the earth is very far. Let us imagine this is a location of the earth. Are you clear? This is the location of the sun, this is the location of the earth. Very close to the sun, the shape of the wavefront will be spherical in nature. When light travels to the greater extent, what will happen? The spherical wavefront travels, and when it is incident on the surface of the earth, a small portion of the spherical wavefront is made to incident on the surface of the earth. So what kind of wavefront is incident on the surface of the earth? Plane wavefront. Make a note. What kind of rays will be received by the earth? Look at that. Here all are divergent in nature, but while traveling to the greater extent, parallel rays are received by the earth. While reaching to the greater extent, see the shape of the rays. The rays are parallel in nature. Okay, while doing distant object method in the lab with the help of convex lens, basically what you are doing, you are keeping the lens very closer to the window. You are catching the image of the long distant object. So the rays from the long distant object, they are in the form of which kind of rays? Parallel rays. All the parallel rays are focused with the help of the lens. So here see the combination. So clear, the parallel rays, they are piercing through the plane wavefront. Are you clear? So the rays, they are all perpendicular to the plane wavefront. Are you clear? Plane wavefront and parallel rays combination should not be forgotten. Are you clear? So when the ray travels to the greater extent, what kind of rays will be received by the earth? Parallel rays. What kind of wavefront basically is incident on the surface of the earth? Plane wavefront. So don't forget parallel wavefront and parallel rays. Okay.